Welcome back to a really, really easy game. The best way to start off an episode is to jokingly allude to something I said between recording sessions. Anyway, yeah, so what I was saying to myself earlier was, I wonder when this game gets hard. And then I realized that makes me sound really, really smug. But I am really smug. So let's go to creative writhing. Adjectives, nouns, prepositions, articles, and Oxford commas, all critical components of clear, unambiguous writing. I'm trying to... They didn't use an Oxford comma because they didn't list 3 things. That's sad. Please enjoy your new command, write. It allows workers to change the number on any data cube they're holding. Yes, you can now write anything in the entire universe you can possibly imagine, as long as it's a whole number between 0 and 99. Make all data cubes say 99. So... what we will do is, I can use the nearest command and be really lazy and get a nice, easy program. So that's what I'm gonna do. And what we're gonna do is write on mem1. Huh. What? Oh. What? Huh? I can assign a number or mem1? That's really weird. Do I need to pick something up? Oh yeah, I have to pick it up, and then we can do the write. I can't just write something on the ground. So what we'll do is we'll pick up mem1 and then write 99 on it, and this should be probably the shortest, easiest version of this code I can do. Now, this probably isn't the most efficient, because what's going to happen is people are going to kind of walk around and walk all over each other and bumble their way through the puzzle. It's probably more efficient to have everyone go down their designated little path here. But... I forgot to have the drop command as well. So, go to the nearest data cube isn't really going to work, because the nearest data cube is the one they're standing on. So watch this. We're gonna pick it up, we're gonna write it, we're gonna drop it, then we're gonna pick it up, write it, and then we're gonna drop it. So I need to then do a step down. This isn't going to work because... well, I mean, yeah, so if I do a step down, then the thing that's not going to work is that we'll never do that one. So, what it needs to be... I'm trying to think of the way to do this with the shortest amount of code. And basically we need to find the nearest cube that hasn't been written yet. So, if it were possible, I would have everyone take a step up and then put it down. But that's kind of not really that doable. That's not very feasible. So, what I have to do instead is when I do the drop, we need to not do this nearest thing, unfortunately. So, everyone takes a step down, and then they pick up their cube, and then if to our left is a data cube, then step left, and we wanted to pick up on that tile and just do that in the loop. If to our right is we can put this in the else, I guess. Yeah, this is going to be not very efficient. This is not going to be the efficient approach at all. So if my item... Okay. So if to our left is a data cube, then we step to the left, and then we do our pick up, right, drop. Else if to the right is a data cube, then we step to the right. Else if it must be the case that we have to take a step down because no data cubes above us will ever be ones we need to write. So else we just take the step down and we do our pick up, right, drop. Let's watch this in slow motion. Not the prettiest code. I don't like the fact that I have this embedded if-else thing going on here. But this should work just fine, and I assume I'm not going to be winning either the size challenge or the speed challenge. So, and my right is not equal to 99. Maybe if left is not equal to 9. I don't know if I can do this check of 99. This will be very interesting to me. So what we're looking for is if this person steps to the right. They did take the step to the right, and that's because of this 99 thing. Let's try this again. And this feels like it might work. If this is not equal to 99. I don't know why we can... So I know that we can check against my item, but I think that this check against just a raw whole number won't work because I don't think they're going to read the data cube value. Actually, they just did read the data cube value. So this... Yeah, okay, this is kind of a cool little trick that I didn't know. So if I compare just against whole numbers, I will actually look for the values in the data cubes, and I can make certain behaviors happen as a result of that. We can just run through the rest of the level here, and... Yeah, I did not beat size. I did not beat speed. I didn't actually do terrible on speed. 42 seconds to 39 seconds, so... I wasn't too far off the optimal solution, but I was fairly far off the optimal size. Still, I'm just going to move on, and we'll do data backup day. In just a moment, everyone. I'm just finishing up an important report I've been working on for over a year. Type, type, type. Type, type. Yes! And done. Excellent work if I say so myself. Let me just save my work here, and file, save as... No. No, no, no. Disk abort fail. What? Stop. Retry. Gah! Who would have thought my entire career would come crumbling down due to catastrophic data loss? Haha. Don't worry, everyone. Did I fool you? Yes, I always knew I could have become an actor if this management job hadn't worked out. Clever. Data loss is something that can happen to anyone. It's nothing to be ashamed of. This is why we make backups. Let's all practice making backups over here. Each worker is a cube on both sides. The bigger number is corrupt. Overwrite this bigger number with the value of the smaller number and place them both back on the floor where they started. Get a new command, set. Set works similar to nearest, but you can use it to remember things on specific tiles, numbers, and many other things. Use the question button over there to learn more. You can use it to remember things on specific tiles. Interesting. Oh. So this is how I'll remember which tile I picked up the larger cube from? But that doesn't really make... do I even need set? I don't think I need set. Basically, I just check if... What are the nearest things that I have? Okay, I don't really want to... I don't want to use nearest at all in this level. So if to the left is less than the right. I wonder if that works. So if left is less than right, then we pick up from the left. Else we pick up from the right. Maybe this works. That seems kind of classy. I don't know if that is programmed into the game to work this way or not, but we'll give it a shot. So what we'll do is we'll remember... No, we don't need to remember anything. Oh, hang on. So mem1 is equal to set nothing. So is this going to set that location as the nearest nothing? I don't know. This might work. So what we do is overwrite the bigger number with the value of the smaller number and place them both back on the floor where they started. So if less is... So if, what we need to do is switch these pickup statements around. So if left is less than right, then we pick up right, because that's the bigger one. Else we pick up left. And our... I guess mem1 should be equal to right, because that's the empty tile. And then, otherwise, mem1 needs to be equal to left. That's the empty tile. We write from... I guess... mem2 would be the value on the left. I guess I do need set for this. And then mem2 would be the value on the right in this case. So it's whatever value is the smaller one. And then we write mem2. And then drop on... And then I guess we would want to... How do we walk to mem1? Oh, there we are. So we step to mem1, drop, and then mem3 will be just the starting tile. So mem3 is equal to the starting tile. And so we step to mem1, drop, then we step back to mem3, which restarts us because that'll put us in the middle here. So mem1 is going to be equal to the position where the data cube we picked up used to be. Mem2 is the value opposite of it. So we write the value opposite, we step to where the data cube used to be, we drop it. It's really weird that drop you can only do on the tile that you're on. But this should work just fine. So let's make this nice and slow and we'll just watch like this guy. So he picks up 95. He writes 30. I can't step to nothing. Huh. So... Huh. So mem1 didn't work. We did the right, but nobody actually made the step to mem1. So when we did this, I thought that would pick that tile, but what it's doing is it's trying to set the value on that tile to mem1. Okay. And if I do nearest nothing, it's always going to be the tile that we're standing on. So that sucks. But what we can do instead of having mem1 be that used for that, what we can do is just say if to our left is a nothing, we step to the left, and we do our... else we step to the right, and we do our drop, and then we step back to mem3. That's really weird that set didn't work the way I thought it would. So we've done our steps. And then, yeah, everyone says you can't step to nothing. Oh, I only needed to do it once. There's not even a loop required. Oh yeah, something puts the mind at ease, like redundant data storage. Haha, yeah, you're telling me. Well, I got the optional speed challenge right. My size challenge was way too much. So we can get rid of this memory set here. We can get rid of jump. And I guess we don't... Wow. Do we even need mem2? Wonder if it's possible to do the nearest nothing. No, not. Unfortunately, I cannot do that. It'd be interesting if I could do step away from something, but I don't seem to have that ability. So I can get down to 12, a program of length 12, which ain't close to 8, but that's fine. I wonder if it's more efficient for me to just say set mem2 is equal to... I can set mem2 equal to itself. That's really weird. Tiles with nothing are like pointers to null, so they aren't really a direction to go. Ah, interesting. I never thought of that. I could have it be the case that if... So we set mem1 is equal to left, and then mem2 is equal to right, and if left is... if mem1 is less than mem2, then we pick up right, otherwise we pick up left. This didn't make it any shorter. We then write... Well, I don't care. Back. And that about wraps us up for today. So thank you all for watching.